Let's take a look at renaming mixed numbers as fractions. So the first thing that we learn is doing this in models. So let's take the fraction or the mixed number 3 2/3 and let's draw it out. So I have 3 wholes, 1, 2, 3 wholes, and then I'm going to have 2/3. So I draw another hole, I break it into thirds, it's a peace sign, or I like to think of it as a stick figure with the legs. That's usually a similar spacing. So I have 2/3, so 3 holes and 2/3. 1/3, 2/3. So that's 1 plus 1 plus 1 plus 2/3 to get us 3 2/3. Now we want to count it all in thirds, entirely in thirds. So what would happen if we broke up our wholes into thirds? I would have how many? In one whole, I would have 3/3 plus another 3/3 plus another 3/3 plus, we already have this as 2/3. So if I were to add those together, 3 plus 3 plus 3 is 9 plus 2 is 11/3. That's how we would model it. But of course, we don't want to draw fraction circles or fraction bars every single time we do a math problem. What if we took the same fraction and did it mathematically? 3 2/3. What we do when we're turning mixed numbers into improper fractions is we take the whole number, multiply it by the denominator. We do that first. Then we add the numerator, and it all goes over the denominator. So, I spoke today about what we did when we turn an improper fraction into a mixed number. When we do an improper fraction to a mixed number, we divide, subtract, and whatever we get when we subtract is the numerator for the fraction. Our remainder is the numerator. So now we're going to do the inverse. We're going to do the opposite. So now instead of dividing and subtracting, we're multiplying and adding. And when you turned improper fractions into mixed numbers, the denominator stayed the same. So now what we can do, another way we can write it is taking this whole number times the denominator. So what happens when we do that? Our 3 times 3, our whole number times our denominator. And then we would add our numerator, plus 2, all over the original denominator of 3. So what happens here? 3 times 3 is 9 plus 2 over 3, which still gets us 11/3. We get the same exact answer. So the reason why we're multiplying is because we have 3 wholes. I don't want to count, if it's thirds and 3 of them, it's not terrible. But if we had 7/56, I don't want to count each of those individual pieces. But I know that there's 3/3 in each whole times, so that's 3/3 in each whole, times 3 wholes. So if we write this out in words, I did this in class as well. So we have 3 wholes times 3/3 per whole, plus our remainder, 2 is our fraction part, and that's all over denominator, because we are counting, let's not put a dash because that looks like subtraction, parentheses, we are counting thirds. We're counting how many thirds. So this method and this method both get you 11/3 as your answer.